Okay, hello everyone. And today I will give you a short overview about the CCVS or Copernicus Calval Solutions project. When I started making this project, I thought I will give you more thorough input of what we did. But as this project was more about communication, reporting, documentation, which means that the slides are more text-oriented. So to have your attention until the end of the presentation, I cut it a little bit shorter to give you a general overview about the project. And if you have any further questions, then we can discuss it afterwards, or you can read in the deliverables. Now, as Lea said, it was a big project. We had several partners all over Europe. It was a really nice thing to have these new people joining our network. And the best way to do it in this way, of course, was that we had planned the kickoff meeting in Tõravere in here to meet all these new people, because with several of those institutes, we have had collaboration before, but from those institutes, there were different departments joining in this time, as some of those are really, really big institutes. However, this project started in 2020, which meant that the first project meeting where people can come together will be held in the end of this month. So this collaboration project, this lot of discussion with people had to be held all online with people you don't know. As during the meetings, most of the people, to save the bandwidth, also turned off their webcam. So a couple of those people I actually met this spring, 1.5 years into the project. Some of them I will probably meet in the end of the month, at the end of the project. So the networking part didn't go as planned in this way. We got some good connections, but due to COVID restrictions, the result wasn't that good. Now, the important thing is that within the project we had in the advisory board people from European Space Agency, from EUMETSAT, from European Environmental Agency, and the Copernicus representative from European Commission, which means that those ideas that we present should be included in future policies, hopefully. So the scope of the project was to define a holistic solution for Copernicus Sentinel missions, and not only including the ones already operational, but also the ones that are planned for the future, so that we can overcome the limitations of current Calval activities. For Tartu, we were leading 3 tasks, and we had to coordinate the first 2 work packages to have them more uniform way. As I said, the project started in the end of 2020 and will finish in the end of this month. Saying about the big project, it was a 3 million euro project where Tartu budget was roughly 10% of it. Now, as I said, I will give a short overview about the different topics that were covered during the project, that you can find all those deliverables that are already confirmed at the project website, which is the ccvs.eu. Half of them are already available. A quarter of them are being confirmed at the moment by European Commission, and last deliverables will be submitted in the end of this month and probably will be available for general public, let's say, in half a year or so, depending on how long the Commission takes to overview those. As results from the work package 1, I keep it really short because this was basically detailed technical descriptions of every mission and their needs for calibration before the launch, during the mission period, looking at potential calibration sites. It's a like moon or stars or something similar things, and we're just listing the parameters to be validated by in situ measurements. So I guess our space department will be interested in some of those details, and I will really instruct them to go to the link and look at those deliverables to see exactly the part they're interested in, and because they are nicely referenced. And this is perhaps a good starting point to compare some of the new satellite missions to see how Sentinel is managing similar mission types. For example, if you're working with an optical camera, how a big camera is handled at the moment. Now, working towards the work package 2, from here on I will go through task by every task and just provide some of the most important remarks, basically. So task 2.1 was about onboard calibration. And for optical instrument, what was found is that there is definitely need for improvement on onboard sources characterizations and traceability to SI. This first sentence will be going through the entire project, not depending on the topic, the traceability to SI, the uncertainties. This is a major issue in the field, and will come up on those slides quite often also. The second thing that came up was that there definitely has to be an improvement on-ground calibration of diffuser. There were some issues found in there. One important aspect is that the aging of the sensor and onboard calibration devices, those models need to be there and studied further, because currently there are some unknowns in there. Can't remember exactly on which Sentinel that there were some issues in there, and as you can figure out, you can't really bring the sensor back after the deployment and do the post deployment calibration that we do for in situ sensors. So you have to really know about your sensor and its aging. One problem that came out was actually that the documentation for the instruments is there, but not available for the public. So if you want to go in there, do the research, you have to go through all these different channels to actually get the documents. So it's not really what the Copernicus open policy is about. So there are some questions about that. For SAR missions, there was a question that monitoring of antenna pattern already before the launch should be done to have to be able to compensate for ad hoc discrepancies. For the natural targets, the general conclusions in this way were easy, that there are, for optical and atmosphere missions, atmospheric component missions, there are a lot of methods available, and most of them are already applied for Copernicus. For altimeter and SAR components, there are a few methods used currently, generally, but most of them are already applied for Copernicus missions. Now, when we look at software and databases, then there is a little bit different, because for optical components, there's again a large set of software and databases that do exist, and most of them are applied for Copernicus mission. However, for altimetry and SAR and atmospheric composition, this is something that's not properly there and needs some work on.
What about the optical component?
I think with copy and pasting, I think it was supposed to be first. That was The optical components should be optical sensors.
Oh.
For software and databases calibrating for optical sensors. Yeah, I think there's a copy paste error there. Again, coming back to the same principle that goes through the entire project, we have a lack of detailed uncertainty propagation and traceability. So we do have those natural targets, and we can use them, but we need an error bar there. Going into task 2.3, which was inter-satellite comparison. To keep it shorter again, I only brought out the general conclusions for flying in tandem configuration. Who wants to read more about there's other options for inter-satellite comparisons, this deliverable is also up there on the website. For the optical component, there's a clear benefit flying the tandem phase in the beginning of the mission, as we can see the differences between the sensors, and it's the opportunity to assess the measurement uncertainty. So there's a clear benefit, and this is probably something that will be followed for every next optical mission. For the altimetry, it's the same that it has been done for some time, and it just doesn't give you the opportunity to evaluate uncertainties, but it's also able to really validate some small-scale differences that you can't measure in some other way. So it gives a totally new option, and this also means that it's improving this way we can improve the understanding of altimeter acquisition modes. For the optical part, we have it easy. We have one acquisition modes, but for altimetry and SAR, we have different acquisition modes, and these need to be tested. For SAR component, this configuration in this way is not tested. This is a little bit different. We have tandem missions in SAR, but it's this is a different approach than flying in tandem configuration as in the mission starting phase. So this is not used because there's a big risk of interference between both satellites, as these are active sensors, and so flying them so close by and having the same two targeting the similar objects can result in, let's say, weird results. That's not so useful. For the atmospheric composition component, the objectives for this tandem missions are a little bit different than for the others, and it's more related to the time series and not so much about uncertainties and precision. Task 2.4 was about systematic ground-based measurements. So this and the next task was a lot about reaching out to people actually conducting systematic measurements, asking the feedback from them about what is right, what is wrong at the moment, how they're doing, and filling in the questionnaire. Unfortunately, we had to do this all online. The original plan was to actually meet the people, discuss them in person, but unfortunately that didn't work out. But the feedback what we got is that still a lot of networks, I'm pointing out here that it is networks, not single institutes, work groups that go out that do their scientific measurements, but networks rely on site-specific and/or manual quality control. Of course, there are other examples that have nice automatic quality control running, but most of them don't. The uncertainty estimation is either missing or with lack of documentation, which is basically the same thing, because if we don't know what's behind their uncertainty estimation, then how can we rely on that? If a network says oh yeah, we have a 3% uncertainty. Yeah, but what does it mean? What have you taken into consideration in there? So if you don't have a proper documentation, it's basically the same as nothing. And but at the same time, we know that several development projects, for example, the FRM for SOC that's going on and being led by Tartu Observatory, similar projects are ongoing to find solutions for this issue. And at the same time, a lot of those networks have long time established this quite good quality flag system that can be used to really filter out the bad data, basically. One of the key issues that came out was, of course, funding. So networks have established their sites. The people have learned how to do this work properly, but they don't have a guarantee funding. So it's like you have the people who knows how to do it. They have equipment to do it, but they don't have the funding to do it, or they're uncertain for the future funding. One big issue is the metadata format. Metadata is collected in a variety of different ways, which means that if you want to put all this data together for some bigger Copernicus-level exercises, this needs quite a lot of work. Some of them have collected, well, let's say all of them have collected a little bit different metadata, not only in the format, but what is actually collected as metadata is also different. And one major thing is that many networks that are involved in those Calval activities, they do collect data. This data is being used, but this data is collected for another purpose. So they're not thinking about the needs of satellites. How the system is set up is for another purpose, for some say in situ monitoring, for example. And so there can be small things that need to be added, but they're not there because they don't need it. Copernicus would need it, but they don't need it. And this is something, some collaboration is needed there to increase the quality of those networks in the framework of satellites. The quality of those networks is decent for its purpose, but from the Copernicus side, its purpose is not so valid. That's the issue. About field and aerial campaigns, of course, the positive sides for those are that airborne and shipborne campaigns, we can collect data from those targets that are not usually covered with automatic measurements with regular sites. For airborne campaigns, we can cover immediately a wider area. So we have immediately a larger spatial extent for Calval site. And drones or other unmanned flying objects can be rather cheap and flexible to go out when there's something extraordinary going on, or some small mapping has to be done that's not possible in some other way. However, most of those campaigns have a targeted, let's say, they're targeted for some parameter, small list of parameters, and that's an issue. And sometimes there's an issue of calibration of those airborne instruments and taking into account the atmospheric part of those measurements, as they're seeing through part of the atmosphere. And going back to financing, what is really special about campaign-related financing is that even if you do have financing for the campaigns, you quite often don't have the financing to do the later on analyzing of the data, or you do have financing for the campaign, but not keeping up the infrastructure. This is either ships, planes, etc., or sometimes instruments that have to be ready to do the campaigns. So going forward, task 2.6, which was about CalVal data distribution services. Here, what we saw is there is a significant advantage for using, for example, this OpenDAP or similar systems where data is stored in NetCDF follow versions. However, this is not in most cases the case, and even if it's stored in the NetCDF format, then it's not always. It's the user guide, the guidelines, implementation guidelines are not always met, which means that the keywords are not used always in the same way. So if you're combining different NetCDF databases and you have different, or it's the same keywords using a different thing, then you're not getting an accurate result. And of course, there's an issue of other formats. There are now coming up those translation models that can be used when you have a database in one sort of format, then you can translate it into a different format. However, this means that the guidelines have to be met really carefully, because those translation programs assume that those terms are used constantly the same way. With the metadata distribution, this things gets more out of hand. For metadata, we have a variety of different ways to put it down. We have just some text documents we have written down, just on paper ones that are not even online versions. We have some properly paired with the data, some not. Some are in some sort of database form that's not machine readable in this way, that can be let's say merged with some other database when there's a will for collaboration. So there's definitely a lot more issues regarding with metadata. And this is also one of the things that came out all the time during the project, that metadata format, how metadata is collected, is somehow being left out from the discussion board quite often. So previously the discussion about the data itself has been strong, but not so much about the metadata. But you can't combine different data when you can't compare the metadata. So keep an eye on your metadata, basically. Now, all those deliverables that I discussed now are already out there on the website, but the task I'm going through now further on, these are at the moment being confirmed by the European Commission. So as soon as we got them agreed, then we will put them out also on the website. So for the task 3.1, there was recommendations for research and development and instrumentation technologies. And let's say the key components coming out from there is that for every new instrument or technology coming out, we have to make sure that those instruments reach the FRM or fiduciary reference measurements level, and this includes the providing best practice documents, standards, protocols, etc. So to provide also a new, let's say a new institute developing or new company developing a new instrument, they have to have a better access to those needs for Copernicus so they can reach this demand, basically. And there is a need for harmonization of data analysis, and this will come back to on some later slides. Keep in mind, we're talking about the calibration and validation about Copernicus mission. I forgot to state this in the beginning of my presentation, is we're not talking about other possibilities to use some of this data infrastructure for scientific work. This is different topic. We're only concentrating on the Copernicus calibration validation needs. And for that, the focus must be that all those new and existing sensors have to be well calibrated and fully characterized to understand them better, to evaluate the uncertainty coming from the instrument. And there is definitely, next point, there's definitely a need for more systematic measurements for airborne, mobile, vessels, ships, buses, or different kinds of vehicles, so we can do an automated measurements and mapping larger areas. However, these devices need to be cheap, because there's no point of having just one on one vehicle. There has to be more to get the effect. And the development of automatic systems, similar to the, for example, for the hipster one that's being developed here in Tartu, should be endorsed to cover the temporal resolution needs, because what we have seen is that one automatic station can collect years worth of campaign data for satellite comparison in the matter of not months, even rather a month. Of course, that depends on what regions you are. If you're here in Estonia and you have a cloudy period, then with even a month, an automatic station, that's not going to help. Task 3.2 was about recommendation of research development on Calvin methods, and the common gaps coming out for that, again, coming back to uncertainty and traceability to the SI. This is a lot of work needs to be done there. We need a further development required in validation coming from radiative transfer model. There are different approaches to being tried out, but certain fixed one for Copernicus needs to be discussed. There is need for a new validation method for spatial atmospheric correction steps like terrain correction. As atmospheric correction was not really deeply, let's say it was touched during this project, but as this is a completely it's so hard topic that it's needs a separate project. So the atmospheric correction itself is not really deeply analyzed within this project. But one important thing is that what we have in the atmosphere is the clouds. However, these are not well defined. For this purpose, there should be a definition of cloud that has a mathematical description. That's currently definitely missing. What is expected is the development of community processors that take into account all these different uncertainties, the different aspects, and because the calculation of all those, let's say, additional parameters is really hard to reach for an average scientist on the field. This is a complex issue that there are not many, coming from my field of water remote sensing, there are not many in our field who can actually tackle this issue. I can name a couple. So expecting every institute to tackle on its own, it's not feasible. So there's definitely need for a community processor to do most of the work for them, expecting that they are collecting the necessary data in following a proper procedure. But this is really expected that this is something that will be from top down, that those community processors are developed from the order from UMATS at ESA or European Commission, and then provided for the general community free of charge and then open source. And there's a need for satellite to ground co-location and harmonization strategies, so that so we don't have the mismatches so badly. Task 3.3, Copernicus measurement network and supersite. Well, that was definitely a task that caused some heated debates, because there are people believing that the term supersite, for example, is well defined and well used already. However, it's not the case for different fields. So the term is being used differently during different mission types, different groups of people, and this needs to be clarified to understand what we're first talking about. But from our project side, we decided that currently we have a lot of measurements already being conducted, and for being the Copernicus measurement network, we have to help those networks to reach the FRM quality. This probably needs some counseling, because sometimes it's just the lack of unknowing some of the issues, not even so much needing additional financing for infrastructure. It's something to do with procedures or a small investment, not needing a massive investment. And one idea was to actually have for the major partners of Copernicus in situ data collections, to have a Copernicus presenter or scientific advisor on the board of those networks to basically guide future developments in this way, that the networks can be more beneficial for the Copernicus program. There is a need to help with uncertainty estimation, so coming back again to the community processors. So both with the documentation and software. And one important thing was that it was asked, should we define, for example, locations for those new Copernicus supersites where we can measure a lot of different things all in one spot, in one place. But the general conclusion was that we don't need that. We need first to see what's in there and develop those, because we have the time series. The time series are really valuable. So if you need to measure different parameters on one spot, then build on the already existing structures. Do not start immediately creating some new things, but build on the existing ones. And the focus should be that we have those sites that we need to have a long-term funding, and the data is following the fairness principle. To use the data from all those different network sites, this data has to be compared. However, it's not possible for most of those to come together for some comparison exercises. So there has to be a higher level standard traveling instrument that's being maintained by a higher institute, either by ESA, UMATS at European Commission, together with some partner institute that can actually characterize and calibrate the instrument constantly. And this traveling instrument will go around and compare the measurements, so that we can see that we can actually compare different sites. Because sometimes we know that there are differences between sites, but as they're in different natural conditions, there has to be differences in size. So to compare the actual numerical values, there has to be some sort of standard to calibrate them to. That should be done also on the field, because some of those parameters, or some of those sensors work well together in the lab, but not so well together on the field. So to understand those issues, there has to be some comparison. The rules for being a CalVal site or CalVal network has to be periodically reviewed to meet the mission needs, and as future missions might have a little bit different needs. And sometimes there's a need, might be even a need for a downgrade or generalization, because this is something, for example, that came out for altimetry, because the FRM for altimetry project basically concluded in this way that there's only one valid site. That the requirements were set in this detail that only one site could actually be valid. And this is something, an issue that basically someone created a monopoly using the project. And of course, there is a need for improved data sharing and distribution. That's always. Now for data distribution. Again, the suggestion is to build on the already existing procedures, existing software databases, and to cooperate those, to extend the capabilities. Especially we need a proper documentation to translate them into interchangeable forms. And some of the data that Copernicus uses for its CalVal activities is Copernicus funded. Most of it isn't. It's coming from outside. So now the question is how to combine those into similar databases. Again, coming back to the metadata, a centralized approach at least has to be there how to collect the metadata if you want to collect CalVal data. And if we are talking about those institutes, network sites contributing to CalVal, then they should follow the FAIR data principles. With sustainability, this is something hard to discuss, because for some of those technological advancements, it's hard to foresee. But there has to be a strong collaboration with different key players to have those data formats, everything similar and not change too often. That changes too drastically. And for that, there has to be governance. EEA, or European Environmental Agency, is already doing quite a lot of projects to collect both being collected data, historic data, and to provide this for scientific research. But there is still definitely some improvements to be made there. There were also discussions about how to actually European Commission as a funder actually have quite a strong position to make this data more uniform that they are not using at the moment. Task 3.5 was about the performance analysis and level 3 impact. So using level 3 as level 3 satellite data, which is either time series, time averages, and further collecting or putting the satellite data together with models, etc. And basically, the main outcomes from there were that again, the need for uncertainties. You can't have a level 3 product with uncertainties if you don't have a proper level 1 and level 2 products with uncertainties. Not going to happen. So as said, the level 3 already takes into account all those previous steps, and to evaluate the product uncertainty, you have to have those. And to validate level 3 products, you have to have a similar level 3 in situ measurements, which means time series, etc. And again, relates to the radiative transfer models that cause some of those issues with reaching for the higher level products in satellite. So task 3.6 Calvel solution. The general understanding is that Calvel activities for Sentinel mission is generally appropriate to meet the scientific and operational objectives of the program. And there's definitely the most critical aspects for the missions are covered, or if there are some issues, they are actively pursue the solution or some ongoing projects. However, all the non-critical ones are not funded by Copernicus itself. The data is collected by collaborative partners or just made available afterwards through some collaboration projects. And there are definitely limitations there. And there's one elephant in the room, that's unknown factor of the Brexit effect. For example, coming from the water side, one important Calvel activity is the transatlantic cruise that's being organized by the PML in the UK. So if the funding connection, if the route connection disappear, sometimes the question is it's out of control of Copernicus, as the rules for collaboration projects before and after Brexit are different. Now going to the work package 4, this is something that I can't show you at the moment because these are being finalized at the moment. They're not even submitted yet. As I understood, and the final workshop will be also accessible through internet. So if you want to see the results concluded in a presentation form, then contact the project and see if you can participate online. And that's it for me. Questions?